How's it going, everyone? In today's video, we're going to be going over 25 tips and tricks that you can start using immediately in your Python code. I do want to put out a huge disclaimer though. I will not be diving into any of these subjects for longer than a few moments. So to get a thorough understanding of these features, I recommend saving and researching them in your spare time. Also, for today's video, we'll be using Zed, the code editor, which is coincidentally today's sponsor. Zed is a lightning-fast code editor written in Rust, and I've been using it to do all my coding for months now. If you feel like trying out Zed, I've left a link in the description box down below where you can download it for free. Anyway, let's get started immediately with the first tip of the day. Tip number 1 is a great trick for debugging. Suppose you have some variables or expressions. Using f-strings, we can provide the variable name or the expression name followed by an equals to immediately print the result. So when we run this, we'll get both name and age and the values associated with those variables. And as I mentioned, this works with any expression. So we can also get the length of name, and that will return the length of name and its length. And one more thing to note is that these spaces are conserved. So if you want to type in 1 + 1 with spaces, you'll see that in the console, all those spaces will be conserved. Tip number 2. Try and except with else. Suppose you have an operation that might fail, such as a division operation, which could result in a 0 division error. If we were to change b to 0, we would end up with that error, but luckily we will have caught it. So everything here works as it should. But did you know that you could also include an else block in your try and except blocks? And this will only execute if there are no exceptions. So with this exception, we will not see the else block being executed. But if everything works in the try block, the else block will execute as well. Moving on to tip number 3. Along with else, you can also use finally in your try and except blocks. And the finally block will always be executed regardless of what happens in try and except. So right here, we are successful with our operation and finally is executed. And if we encounter an error, finally will still execute that code. So finally works just as it would in any other situation. Obviously, Python has to be running to reach the finally block. If your computer switches off, or there's an error that shuts down Python or terminates Python before it can reach the finally block, it will not run. Tip number 4. For this example, we're going to create some names, which will be a list of type string. And what I'm going to show you are some optional print arguments, which are very useful. So here we're going to print the names, but we're going to unpack them as well. And we're going to create a separator, which will be a comma, followed by an end, which will be a new line. And before the new line, we will add a full stop. Now, when you run this, you'll see that we will have a very nicely formatted output thanks to the separator and the end. And for those of you who are new to unpacking, what this does right here is practically just insert all the elements from our iterable as separate arguments. But obviously, it looks a bit cleaner when you use the asterisk. Tip number 5. Did you know that strings are iterable? That means that we can treat them like read-only lists. So, for example, if we want to extract elements from a string, we can use this unpacking syntax. And now when we print first and last, we should get the first letter and the last letter. This also means that we can unpack the string and then apply cool effects such as a separator between each letter. And finally, we can loop through them just like any other iterable. And what we should get is a very long form of James. Tip number 6, combining sets. For this example, we will have 2 sets of type integer. Now imagine you want to combine these. The easiest way to do so is to create a new set and then type in A pipeline B, which will perform a union operation. Now when we print C, what we will get as an output is the result of that union operation. If you don't feel like creating a new variable, you can also perform the in-place operation using pipeline equals, and then print A. And this will update A to contain the result of that union operation. Tip number 7. What I just showed you with the union operator also applies to dictionaries. So we can perform the exact same operation on these 2 dictionaries. And when we print C, we will get the result of that union operation. Or once again, you can do it in place and print A. And that will work as well. Tip number 8. Did you know in Python you can create a decorator which automatically invokes a function? Well, you can. And the easiest way to do so is to create a lambda which takes an underscore as an argument and runs that underscore immediately. Then you can create the function you want to run automatically, and as soon as Python encounters this function, it will run it. You do not need to explicitly call it anywhere in your script. In JavaScript, this is known as an IIFE, which stands for Immediately Invoked Function Expression. And usually you'd have this return something, which in this case we could return 10, change this to an integer, and now every time we run this script, setup becomes this value. If we were to print setup, you'll see that we will get the value of 10 back. Is there a use for this in Python? I don't know. I've never seen it being used in Python before, but it's still fun to know about. Tip number 9. Did you know that Python has special syntax for displaying an infinite reference? Well, let me demonstrate that. If you were to create a list, such as A, and then append A to itself, when you print A, what you will notice is this funky syntax, a list with an ellipses inside it. This is a very clever way of showing that we've inserted an infinite reference to A, because otherwise Python would have to print this indefinitely. So it'd be 1, 2, and then insert A again, which is 1, 2, with A again, 1, 2, indefinitely. There isn't really a logical way to display this without creating a black hole. Tip number 10, looping with an else clause. For this example, we have some names, and what we're going to do is print each name. And finally, we're going to provide the else clause, which is my second favorite clause next to Santa Claus. I'm just kidding, of course. Or I guess I'm not. Anyway, here we're going to print that all the names were printed. And when we run this, we should get Bob, James, Sandra, Luigi, and the print statement that states that all the names were printed. So what's going on here? Well, if a for loop manages to loop without breaking, the else block is triggered. And I like to refer to it as a completion block because it managed to complete the for loop without any problems. As soon as it encounters a break, the else block is ignored. And else also works with while loops. Tip number 11. You might be familiar with a list comprehension. It's a very quick way to create a list with minimal syntax. For example, here we're creating a list that uses the range of 3 to insert 3 numbers into it and materialize it. And what that means is we end up with 0, 1, and 2 inside a list we can see. If we were to just print a range of 3, we would get a range object back, which in this example is not what we want. So list comprehensions can be quite convenient for creating lists in a single line. But did you know that you can also use the same syntax for sets, dictionaries, and generators? To create a set comprehension, you do the exact same thing as you would for a list comprehension, but you use curly braces. Then for a dictionary, you need to create a key and a value pair, and then loop through some sort of iterable to extract some more values. And finally, for a generator comprehension, you just use parentheses instead of angle brackets or square brackets. Tip number 12. Did you know that it's the comma that defines the tuple, not the parentheses? So in this example, we created a point with the values of 1 and 2. We do not need parentheses to create this point. If you want a tuple with a single element, you still need to include the comma. And the parentheses are not required here. You can type in 2 comma, and that will work just fine. My code editor places them automatically just for readability. If you were to type in 2, this would be an integer. You need the comma to create the tuple. The only exception is an empty tuple. This does not require a comma. And my recommendation is that you use parentheses for clarity. But again, they are completely optional. So if you were to type in 10 and 2, this is fine, especially if you're using multiple assignment. But you'll notice that when you print it, it will always contain the parentheses, which is great for readability. Tip number 13. Unpacking keyword arguments to create reusable settings. For this example, we're going to create a variable called settings, which will be a dictionary with string keys and string values. And here we're going to insert a separator, which will be this comma, followed by a space, and an end, which will be an exclamation mark, followed by a new line. Then we're going to create some names, and finally we're going to print those names, and using the double asterisk, we're going to unpack the settings. And when we run this, print should now use those settings. which is a very convenient way to create settings for functions. All you need to do is make sure that the key value pairs that you are creating exist inside the function you're trying to use them in. If you insert a key that doesn't exist, you will run into an error. Tip number 14, reusable slices. By this point, you might be aware of the regular slice syntax. You have the start point, the end point, and some sort of step. But in Python, we also have the option to create reusable slices. So here we have two slices which I created, which will be of type slice, and the first one grabs the first three elements with no step. The second one ignores the first two elements and reverses it using a step of -1. The equivalents look like this: -1 and 0, 2, 3 with nothing else. The benefit of doing this is that we only need to define the slice once and then use it wherever we would use the slice. So if we were to create some numbers and run this, the first one would grab the first three elements. The second one would reverse it. And these slices work on any sequence. So now we can create some names and use it once again down below. So the first one will grab the first three names and the second one will reverse the names. And the major benefit of doing this is that we can change the implementation at any point in a single place. So this is a huge win for reusability. Otherwise, we would have to hard code this in every spot, which means if we want to change first 3 to first 4, we would have to change this in many places, which is a huge no-no in programming. You want things to be as reusable as possible. So going back to first 3, what we're going to do is refactor and type in first 4, and then change the implementation in one spot. Now we are cool again. Tip number 15. Sometimes you're going to have some very simple variables to define, such as a is equal to 15, b is equal to 10, and c is equal to 5. What sucks here is that we used 3 lines of code to write this, and there wasn't really a good reason to do this. So for simple assignments such as this, what we're going to do instead is type in a, b, c equals 15, 10, and 5 on a single line, which doesn't take away from readability, especially when it's so simple. The only downside here is that we cannot use type annotations in combination with multiple assignment, but otherwise we can use these variables as normal. Moving on to tip number 16, enumerating in loops. For this example, we will use the names that I've used up until now, and then what we're going to do is type in for I and value in enumerate names, print I and the value. And what this is going to do is enumerate those names, giving them an index, which is quite nice for listing items. Tip number 17. A lot of you might be tempted to type in I plus 1 if you want the value to start at 1. And this works just fine. But did you know that enumerate has an optional argument which allows you to pick a start? To use it, you can either use the keyword argument, start, or just pass it in as an argument, and it will start from that point. Personally, I like to be explicit here and type in start, since a lot of people don't know this exists, so this gives them a quick clue of what that is, in case it's the first time they encounter it. Another thing to note is that this number can be negative. So you can start this from -100, and it will enumerate upwards. Tip number 18. I'm going to show you how to safely retrieve values from dictionaries. In this example, we're going to create some settings, which will contain a volume at 30% and a brightness at 50%. Usually, to retrieve a value, you would type in the dictionary, followed by the key you want to retrieve the value for. And code editors these days are quite smart and can tell you what keys are present inside the dictionary, such as volume and brightness. But sometimes you might make a typo, such as volume, and then get an error as a consequence, which might or might not be what you want. In general, it's good to get exceptions for mistakes you make, because that gives you an opportunity to fix them. But a safer approach to retrieving values from a dictionary would be to use the get method. So here we can type in volume, and if it doesn't find it, it returns none without crashing our program. If we insert the correct key, it will give us the value back. And maybe we try to look for a key that doesn't exist, such as weight, and instead of crashing, it returns none. So we can safely continue with our program or tell the user that that key does not exist. Optionally, you can also provide a default value such as 0.0. So instead of returning none, it's going to return 0.0 when we insert a key that does not exist. Tip number 19. Conditional one-liners. For this example, we will create a volume of type float, which will be set to 30%. And what we want to do is create a variable called loudness, which will depend on the value we use for the volume. So here we're going to create a string if the volume is greater than 60%. Else, we're going to create another string. And at the bottom, we will print the loudness. When we run this, we will get silent because the value was less than 60%. But if we change this to 70, we're going to get loud as an output. So here we were able to do all of that on a single line. Otherwise, it would take around 4 lines to achieve the same result using a regular if-else block. And this syntax can also be used directly inside the print statement or anywhere an argument is accepted. And you can also use this to execute code. You can print loud if the volume is more than 60% or greater than 60%. Otherwise, you can print silent. This will work as well. Although preferably, I'd use it for assigning values to variables, if the logic is quite simple. Tip number 20, comparison chaining. In this example, I'm going to ignore the simple trick I taught you about multiple assignment and create 2 variables that contain the value of 10 and 20. Now, instead of checking whether b is greater than 15 and 15 is greater than a, and executing whatever code there is, we can simplify this to if b is greater than 15, which is greater than a. Both of these lines perform the same check, but here we were able to chain operators, which is very convenient. And there's no limit to how many you can chain. You can also check whether a is greater than 0 at the end. And you can mix and match these as you please. As you can see, I'm using the greater than operator, the not equals to operator, and the less than operator all on a single line. And Python will accept this. Tip number 21, using min and max with a key. For this example, we're going to create some scores. And what we want to do is print the max of these scores. Right now, if we were to pass in scores, Python would have no idea how to compare this. So we will end up with this type error. Now what we're going to do is provide a key to fix this. So we'll type in lambda student, and we will tell Python that we want to use the score field to compare them. Now when we run this, we should get Sandra as an output because Sandra has the highest score. If we duplicate this and change this to min, we'll find out that Bob has the lowest score. So the key argument is quite useful for telling Python which value you want to use to grab the max or the min. Tip number 22, in-place operations. And I'd like to thank PizzaPost1234 for suggesting this. Practically, instead of typing in n equals n plus 1, what you can do instead to save time is type in n plus equals 1. This will perform the same operation, but it's a bit shorter. And what's cool about this is that it applies to every other operation. So you can do minus equals, times equals, divided by equals, floor division equals, modulus operator equals, and power equals. And this will save you the trouble of having to type in n more than one time. Tip number 23, the Walrus operator, as suggested by Jason B9T. What the Walrus operator allows you to do is to use a value and assign it at the same time to a variable. So for this example, we are printing 10 and assigning it to n at the exact same time, which means we can use n later. As a result, we will get 10 and 10. A very convenient place to use this would be in a while loop. So here we're using while user input, Walrus operator, input, we will print that user input. At any point, if input is empty, this will evaluate to none and it will exit out of the while loop. So if we were to run this, we can type in Bob, hello, and if we tap on enter, input will be none, which means user input will be none. And this will evaluate to false, effectively exiting out of the while loop. And there are a lot of other places where you can use the Walrus operator, so I definitely recommend looking into it. For tip number 24, we have type hinting, which was suggested by bin2. Here we have a function called getLength. In the old days, you would not see any of this. You would just see getLength, text, and return the length of text. Unfortunately, this does not give much context to the code editor. What are we getting the length for? Of course, text could be a string, but some programs might type in var or some sort of input. What is input? The code editor has no idea. And if we insert the wrong type here, the program will crash. By providing types, we help the code editor understand what types should be accepted. Here we're telling the code editor that text should always be of type string, and that this function will return an integer, which means if during the coding process we return something else, such as a string, your code editor will be able to warn you that something is wrong. You are returning the wrong type here, which is very handy for catching mistakes during development. So right below, we're going to create a text of type string, which contains this insightful text. Then we're going to grab the length using our getLength function and print the length. And as an output, we should get 29. Now, every time we insert an incompatible type, the code editor will warn us that we're doing something silly. Maybe we wanted to get a length of type string. If we were to tell Python that length should be of type string, this function obviously returns an integer, which is the wrong type, so we get these red squiggly lines. And just a quick warning, type annotations are for you and the code editor only. Python will not stop you from running your trash code, even if you insert the incorrect type. So if you were to type in 1 and 2, which is a list and not a string, Python will still be able to run this. There's just a chance that this function will not work because we're passing in an incompatible type, and this function was not designed for lists or anything else but strings. So passing in something such as 100 will crash the program. But we were warned that we were doing something wrong. And finally, for tip number 25, we have guard clauses. And the idea here is to avoid indentation hell, because the more if-else blocks you have, the harder it becomes to keep track of indentation and logic. Guard clauses can clean it up by removing that extra level of indentation. The way it works is that we check whether a condition is met, and if it isn't, we return immediately. Once we make it through all the guards, we execute the success case. And what's nice about this is that it's easier to follow the logic, there's no messy indentation, and there's one true path. So, if you ever end up in indentation hell, consider using guard clauses. It just makes it much easier to follow the logic. But yeah, that just about covers everything I wanted to talk about in today's video. Those were 25 tips and tricks which you can use in Python immediately. But I'd love to hear in the comment section down below which of these you thought was the best tip and trick of the day, and whether you have any of your own. If I see enough comments, I'll even create a follow-up video to this one, including more tips and tricks. But with all that being said, as always, thanks for watching, and I'll see you in the next video.